Welcome to the next lecture on the course Descriptive Statistics with R software. You may recall that in the earlier lectures we had discussed different aspects related to statistics, and we have understood that whenever we want to do any statistical analysis, how are we going to start and how we are going to control the process of obtaining the observations, the different types of associated variables, discrete, continuous, etc. So now I assume that we have collected a sample, and as I said earlier, I will always be assuming that my sample is representative, which means that all the salient features which are present in the population, they are also present in my sample. So now we are at a place where we have collected the observations, and now we want to move further. So first of all, whenever the data comes to our hand, as I told you that there are two options we can start with. One is graphical tool and another is analytical tool. So first of all, I will try to take the first analytical tool, which will give us an idea that how are we going to combine the data, present the data, and how we can do it, which will give us some information that is contained inside the data. And based on that, we will try to take further decisions that what type of graphical tools and tools for analysis of the data can be used. So we start this lecture, and first we are going to address that once the data comes, why it needs to be classified. You can always assume inside your mind that whenever you conduct an experiment, you will get the data. Now, I am also assuming that the data is collected on the relevant variable which you want to study. For example, if you want to study the height, then the data is on the height. If you want to study the weight, then the data is on the weight. So now you have collected the data. This data can be 20 observation, 100 observation, 200 observation, to millions observation, to billions observations. So in case if all the values are just before you, can you really get an idea of what is the information hidden inside it? It is very difficult, because as I said, data cannot speak. Data cannot come outside of your computer or outside your experiment to tell you that, okay, I have this piece of information. This is only you who has to use the appropriate tool to get it out, to take it out. So first thing what we try to do, we try to rearrange the data in some required format. And for that, we would like to classify the data into different groups and from different aspects. For example, I can make the groups of those observations which are similar or which are also dissimilar. All those units which looks similar to each other, they can be put into one group. Similarly, all those units which looks similar, they can be put in another group, and then based on that we can extract the information, different types of information through those groups. So this is what we are going to now study. So the classification of data consists of a very simple thing, that this is a simple process of arranging the data into groups or classes according to resemblance and similarities. Okay. Now, what are the functions of this classification? Why do we make this classification? The biggest advantage is that this will condense the data. You can assume that on one of the walls, different numbers are written continuously. And if you try to look at those numbers, there are thousands and 10,000, 1 million numbers. You can't get any information out of that. So you need to condense the data. So one of the important objective of classification is this, that we would like to condense the data in such a way from where we can withdraw some relevant information. And whenever you are trying to make a statistical experiment, generally your objective is to compare something. For example, if there is a new medicine which claims that this can control the body temperature for say 12 hours, then you would like to compare it with the earlier existing medicine, that whether this improvement is happening or not. So this condensation of the data or the classification of the data has to be done in such a way which can help us in comparing different types of things, different types of aspects, different types of quantities, different types of natures. And in many situations, usually we are interested in studying the relationship. For example, modeling, statistical modeling is a very popular word, which is nothing but a sort of relationship. We want to find out the relationship between input and output variables. So the models cannot be obtained in a single shot. The models are obtained on the basis of statistical data, and this is the starting point, means our descriptive statistics. From there we try to gather the data information in small pieces, and then we try to combine them together in getting a model. So we would like to condense the data in such a way which helps us in studying different types of relationships. And the data has to be condensed in such a way, or the data has to be grouped in such a way that is compatible with our statistical tool also. This is the thing what we always have to keep in mind. Usually people do what? That first they will collect the data and then they will try to choose the statistical tool. What I always suggest is that you first try to fix your objective and then try to see what type of a statistical tool can be used to fulfill or to give an answer of that objective, and whatever is the requirement of that tool, try to collect your data according to that, and this will help us. So another important function of classification is that this should facilitate the statistical treatment of the data. So now moving further, first let me introduce the basic definition. This is absolute and relative frequencies. One thing I would like to make it clear here, that in order to teach in this course I have two options, that first I try to take the theory, formulas, etc., and then I try to pick an example. But rather I would prefer in most of the situation that I should start with an example, and then I try to develop the theory so that you can make a one-to-one correspondence between the theory and the data definitions. That will help you in applying or choosing the tools in our software. Okay, so now let me take a simple example. Suppose there are 10 persons who participated in a test and their results were declared. Their results were declared in two categories, either they passed or they failed. So the candidate who has passed, he or she has been assigned the letter capital P, and the candidate who got failed, he or she has been assigned the letter capital F. So now you can see here that this is here the data of 10% who either got pass or fail, and their outcome is recorded here as say P, F, P, F, F, P, P, F, P, P. Well, I am trying to take here a very small data set which you can see from your eyes, and whatever mathematical manipulations I am doing, that you should be able to see from your own eyes. But you can always think that this data can be very, very large. There can be 10,000 candidates, there can be 1 million candidates, there can be 10 million candidates. So now how to combine this data, how to condense this data? So we are going to use the concept of absolute frequencies and relative frequencies to condense the data, and then later on we will try to put them in some proper format, for example in the form of a table, to get more clear information. So now I would try to denote here the two categories. There are two categories. one is here pass and say another is here fail. So, I can now in general represent these categories as say here A1 and here A2. So, this A1 category will represent the candidates who have passed and A2 category will represent those candidates who have failed. So, now I have introduced here a word category. So, now you can see category contains all the observations which are similar to each other. For example, the category of candidate who passed, this will contain all the candidates who have passed. The category fail contains all the candidates who got failed in the test. Right. So, these are called categories. So, I can see here that there are some number of candidates who passed and some number of candidates who failed. So, let me count it. So, firstly let me count here how many candidates passed. 1, 2, 3, 4, 5 and here 6. So, there are 6 candidates who passed. What about fail? 1, 2, 3 and 4. So, there are 4 candidates who failed. So, now this number, the number of candidates who passed and the number of candidates who failed, this is denoted by say N1 and N2, N1 and here N2. So, this category, this is here N1 and this category, this is going to be denoted by here N2. And this number N1 and N2, they are simply trying to represent the number of candidates in the category A1 and in the category A2, or simply the number of candidates who failed or the number of candidates who belong to category A1 or the number of candidates that belong to the category A2. So, this N1 and N2, they are simply trying to represent the number of units present in the category A1 and A2. So, the number of observation in a particular category, they are called as absolute frequency. Now, one of the drawback in absolute frequency is that, means if I try to give that okay, there are 100 candidates who passed, there are 300 candidates who failed. But you are not trying to see that how many candidates appeared. So, in order to incorporate this feature, we have a concept of relative frequency. For example, there are 6 candidates which passed, there are 4 candidates which failed. I can also say that there are 6 candidates out of 10 who passed and there are 4 candidates out of 10 who failed. So, I can denote the relative frequency of the class A1 to be the number of persons in the class divided by total numbers. In total number of observations that are available, and N1 is the numbers in A1. And this is denoted as say here F1. F1 is going to be N1 upon N1 plus N2. So, this is called relative frequency, and in this case this number is 6 upon 10 because we have observed 10 data sets. So, that is 0.6, or this can be called as 60%. So, I can say that there are 60% candidate who passed. And similarly, the relative frequency of the second class A2, that is denoted by F2, and the definition of F2 is the similar to the definition of F1, that is the total number of elements in the category A2, total number of elements in category A1 divided by total number. So, that is going to be the number of candidates who failed, that is 4 divided by 10, which is here 0.4, or I can say 40%. So, this will give us an information about the number of candidates who pass or fail with respect to the total number of candidates who appeared in the examination. And this can also give us the number in terms of percentage. So, this is the basic idea of the absolute and relative frequencies. Now, next question comes, how to compute this absolute and relative frequencies in the R software. In order to compute this absolute frequency, first we need to define our data vector. The data vector, as I said in the earlier lecture, the data vector will consist all the numerical values and they are combined using the C operator, right. So, I can say here that any data vector that is going to be in the format of C, and then here the value x1, x2 up to here xn, means if I assume that there are n values. For example, in the earlier case there are 10 observations and is going to be 10 and so on. And so, after this the command to obtain the absolute frequency is table, T-A-B-L-E, all in small letters. So, when I try to write down this command table and inside the bracket the data vector, then this will create the absolute frequencies of the data which is given inside the arguments under the vector data vector. And suppose you want to find out the relative frequency. So, now if you try to understand what is the relationship between frequency and relative frequency. Frequency means absolute frequency. The relative frequency is absolute frequency divided by total frequency. Total frequency means total number of observation. So, once I am trying to write down all the observation in a data vector, then whatever is the length of the data vector, that is your total frequency. So, this total frequency can be computed by the command length. A length, and inside the brackets you have to give the data vector, say here x. So, now in case if you want to find out the absolute frequency, then I simply have to use the same command table, and inside the arguments I have to give the data vector, say here x, and I need to divide all the values by length of x. Remember one thing, length of x is going to be a scalar value, but now if you recall, when we did the division operation of a data vector with respect to a scalar, then we had learned that when the division happens in each and every element of the data vector. So, this value will give us the absolute frequency divided by total number of observation, and this will give us the information about the relative frequency. So, now let me try to take an example and try to show it on the R software also. So, for example, I will take the same example, but now I am doing one thing more. Means earlier all the 10 candidates who were categorized in two categories as pass or fail, now I will try to assign them an indicator value, because as we discussed in the earlier lecture that unless and until you try to assign a numerical value to a data, we cannot operate any statistical tool. So, now I have here two values, one is here pass and another is here fail. So, what I try to do here for pass, I try to represent it by number 1, and for fail I try to represent it by number 2. Once you do it, then this data P, that will be represented by 1 and this F will be represented by 2, and similarly wherever is your P, that will be replaced by 1, and wherever is your F, that will be replaced by 2. So, now this is our data, and now I need to type this data into a data vector before I can expose this to R software. So, you can see here that I have created here a data vector like this, and you can see here this one is here this one, this 2 here is this 2, this one is here this one, this 2 here is this 2, this 2 is this one is this one is this 2 is this one is here 1, and this one here is 1. And based on that, I have created my data vector here result. So, you can see here the outcome, and here is the screenshot of the same result. Well, I will show you on the R console also, but before let me try to explain it, and then it will be more convenient for me to show it on the R software. Now, I will simply use my table command and I write here table, and inside the argument I type the data vector name, that is result. As soon as I write here table and result inside the argument, it will give us this type of argument. So, first we try to understand what is the meaning of this result. You can see here there are 4 numbers here, 1, 2, 6 and here 4. So, what this 1 is indicating and what 2 is indicating? First of all, this 1 is indicating the category, your category 1 and then category 2. And now, what this 6 and 4 are indicating? 6 is indicating the number of elements in category 1, and similarly this 4 is indicating number of elements in category 2, and this is nothing but these are your absolute frequencies. 6 is the absolute frequency of category 1, that is class 1, and 4 is the absolute frequency of class 2. And similarly, in case if you want to obtain the same result with respect to the relative frequencies, then what we have to do? I would write here the same command table, inside the arguments the data vector whose name is result, and I would divide it by the length of the data vector. Once you do it, you will get here an outcome like this. What is this showing you? You can see here there are 4 values 1, 2, 0.6 and 0.4. This 1 and 2, as earlier, they are trying to show you the categories, category 1 and category 2. And 0.6 is actually 6 divided by 10. 6 here is N1 and 10 here is N1 plus N2, where you can see here N1 is equal to 6 and N2 is equal to here 4. And similarly, this 0.4 is 4 upon 10, which is here N2 divided by N1 plus N2. So, this 0.6 and 0.4, these are the relative frequencies of categories 1 and 2 respectively. And this is here the screenshot that we are going to get when we try to execute this thing on the R console. So, let me now first come to R console and try to show you here that how the things are happening. So, first I will try to create here a vector here result, and then I will try to show here different thing. So, you can see here I have created here a data vector result like this. Now, I would try to create or try to find out here the absolute frequencies by using the command table table, and inside the argument I will say the data vector whose name is result. So, you can get here the similar output that I discussed. This 1, this is indicating the category 1, this 2, this is indicating the category 2, this 4, this is indicating the number of elements in category 1, and this 4 is indicating the number of elements in category 2. But definitely this is going to give you the result in terms of absolute frequency. Now, in case if you want to have this result in terms of relative frequency, then first I will show you that what is the value of here length of result. This you can see here, this is 10, and you can count here 1, 2, 3, 4, 5, 6, 7, 8, 9 and here 10. So, there are 10 values in the data vector result. So, now if I try to write down table result divided by the length of result, then the outcome comes out to be like this one. So, you can see here this 1 is representing the category 1 and this 0.6 is trying to denote the relative frequency of class 1 and this 2 is denoting the category 2 or class 2 and this 0.4 is denoting the relative frequency of the class 2. So, this is how you can obtain the absolute and relative frequencies, and these absolute and relative frequencies you can see they will be more prominent when you have a qualitative variable. Now, give you an idea whatever we have done here, I will try to put them in the right words. So, I had a set of data of 10 candidates in terms of 2 categories A1 and A2, pass and fail, and we have found the number of persons who are pass and number of persons who are fail categories. So, and then I would try to, or I would say that I have rearranged the entire data sets into 2 groups. So, this arrangement of ungrouped data into grouped data, this arrangement of ungrouped data in the form of group, this is called the frequency distribution of data. That is a standard terminology and we always call it, please create a frequency distribution. That means you need to group the data and then you have to condense the data. Condense means you can see that the 10 data values have been condensed only into two categories and they are based only on 2 values 6 and 4, means 6 is the frequency of class 1 and 4 is the frequency of class 2. And now, what we try to do, whatever is the data, this data is condensed into different groups and for that I try to create different groups. For example, this groups A1 and A2, they are not coming from sky. You are the one who has created these groups as pass or fail. So, I will try to divide the entire data into different groups and these groups are called as classes. So, the meaning of a class is simply a group and for the given set of data we always try to create suitable number of groups. Well, I am saying here suitable number of groups, well there is not a very hard and fast rule to decide how many groups can be there. For that you have to use your common sense and some basic information about the experiment to decide that how many groups can really help you in getting the data or the information which is contained inside the data. Means obviously if the number of groups is too small or too large, then possibly it will be more difficult to handle the data. So, we need to have some suitable number of groups that we will try to see with some lectures in the coming slides. Now, in every group you have to define the boundaries. For example, in this case where we have only pass or fail, well there are no mathematical boundaries, but they are categorized only by 2 this categories pass and fail. But suppose you try to record the age or height of say some number of candidates, then the age can be 5 years, 7 years, 9 years, 12 years, 20 years, 18 years, 21 years, 30 years and so on. So, these ages can be defined in some groups like as 5 years to 10 years, 10 years to 15 years, or this can be 0 to 10 years, 10 to 20 years, 20 years to 30 years and so on. So, in this case they will be representing our class. So, whenever we are trying to define a class, there are going to be 2 values. One is the lower boundary of the class and upper boundary of the class, and these are called as lower limit and upper limit. And when we are trying to find the difference between these 2 limits, the lower limit of the interval and the upper limit of the interval, then this is called as width of the class or class interval. And when you are trying to define a class, there are two values, lower value and upper value, and this will be a sort of interval. Now, whatever is the value in the mid of this interval, this is called as mid value. And the advantage of this mid value is that when we are trying to group the data will be scattered over the entire interval, but we assume that that entire set of data is going to be concentrated only at the mid value. So, in case if you try to see here, what will really happen? Suppose I try to take here two intervals, say age is 5 years, age is say here 10 years, and age is 15 years. And suppose I try to collect the data, the age comes out to be 7 years, it will come here, age comes out to be 8 years, that will come here. Now, age will come out to be 9 years, that will come here, and so on. There will be many observations in this interval. And similarly, all those ages which are lying between 10 years, 11 years, 12 and so on up to 15 years, they will be lying in this interval. So, all these values are lying over here in this interval at different locations, but we assume that once they are grouped, then all are going to lie in the mid of the interval, and the mid of the interval is simply going to be 5 years plus 10 years divided by 2 is equal to 7 years 6 months. And similarly, here the mid value is 10 years plus 15 years divided by 2, this comes out to be 12 years and 6 months. So, this is what we assume, that the value of the variate lies in the middle of lower and upper limits. And whatever is the number of observations which are lying inside a particular class, this is simply called the absolute frequency, or in simple words we also call it as frequency. And when we are trying to divide this absolute frequency by the total number of observation in that class, then this value is called as relative frequency of that class. Now, there is another aspect which is cumulative frequency. What is the cumulative frequency? As the word suggests, cumulative means you are trying to accumulate, you are trying to add more and more. So, the cumulative frequency is also defined to a particular class, and this is defined for all the classes separately. So, the cumulative frequency corresponding to any variate value is the number of observation less than or equal to that value, and this cumulative frequency corresponds to a class, and which is the total number of observation less than or equal to the upper limit of the class. What does this mean? Okay, let me try to take an example and try to illustrate all these things, then it will become more clear and easy to understand. Now, in this example, there are 20 participants who participated in a race, and the time taken to complete the race is recorded in seconds. So, this 32 means that the first participant took 32 seconds, this 35 means the second participant took 35 seconds, this 45 means that the third participant took the 45 seconds and so on. Now, what you have to look here, this is very important, and yeah, I would also request you that you please try to concentrate on this example, that how I am trying to create class intervals and what are the steps which are involved, because in this lecture I am going to explain the example in detail, and in the next lecture I will try to implement the same example in R software, and when you are trying to implement it, it is important for you to do the same steps in R software which you are doing here. Okay. So, now looking at this data, first we try to see what is the minimum value in this data and what is the maximum value in this data. So, I can see here that 32 is the minimum value and here 84 is the maximum value. So, the minimum value is 32 seconds and maximum value is 84 seconds. Now, looking at these two values, minimum and maximum, I have to define here the width of the class interval. And this width is going to decide the number of intervals also. So, by looking at this data, suppose suitably I choose that the width of the interval should be of 10 seconds. So, I try to create here different classes like this. Class 1, say here A1, this is consisting of 30 to 41 seconds. That means this interval A1 will contain all the values of the time which are lying between 30 seconds and 41 seconds. And similarly, the next class is A2, which will contain all the values between 41 seconds and 50 seconds. And similarly, I have here class A3, A4, A5 and here A6. So, I have created here 6 classes and you can notice that all these 6 classes, they can contain all the data. And that is another point while creating these groups, that these groups and their limits have to be defined in such a way such that the entire data can be accommodated among these groups. And now in this group you will see here this 30 and 41. This 30 is the lower limit and 41 is the upper limit. And similarly, in this case in the A6, 81 is the lower limit and 91 is the upper limit. So, now I have created the groups in which the entire data can be summarized. Now, I will try to present it in some suitable tabular form so that I can easily understand it. So, now you can see here I have created a table and the first column here is class interval. And in this interval you can see here that I am trying to give the same class interval which I had denoted here as A1, A2, A3, A4, A5 and A6. And then in the next column I am finding out the midpoint. So, the midpoint of class A1 is 35.5, which is coming from 30 plus 41 divided by 2 and so on. And similarly, I have found the midpoints of other classes. So, we are going to now assume that whatever data is spread in the interval 30 to 41, this is going to be concentrated at 35.5 and our point of reference will be 35.5, that I will say that the data, that all the data in this interval will have the single value at 35.5. And as I said earlier and we had discussed in the earlier lecture also, once you try to group the data, the information on the individual information is lost, but only the information on the data is available that this data belongs to which category or say which class. Now, after this, this is the third column in which I am trying to count the absolute frequency or frequency. For example, here this is the interval 30 to 41. So, if you try to look at the data, how many values are lying between 30 and 41. So, this is here the first value, this is here the second value and this is the third value, fourth value and you can see here this is the fifth value here. And similarly, if you try to find out here how many values are lying between 41 and 50, I can say here this is the value 45, 1 and then if you move further 42 second and then 42 once again here 3. So, there are only 3 values which are lying between 41 and 50. So, you can see here this is represented here, where I am trying to make a circle. And similarly, I have found I have counted the number of observations in that particular category, and I have done it manually, and I have written here. So, this 5 is indicating that there are 5 values in the interval 61 to 70 and so on. Now, the total number of observation here you can see is 20, and this we try to denote by here n, this is equal to here 20. So, now when I try to divide the absolute frequency by the total number of observation, I get here the relative frequency in the next column. So, you can see here this 5 is coming here, this 3 is coming here, this 3 is coming here, and this is here the total number of observation. And once I try to divide it, I get here the values of relative frequencies. The advantage of relative frequency is that all the relative frequencies, they will always be lying between 0 and 1, and so they can be easily converted into percentages. Now, in the last column I am trying to find out the cumulative frequency, and here I would like to once again explain you that how these cumulative frequencies are found. Now, this is my here I can rewrite here class A1, class A2, class A3, class A4, class A5 and class A6. Now, I am trying to say the total number of observation in the given set of data in class A1 is 5, or this A1 is having the limit 30 to 41. So, I can also say that there are only 5 observation in the entire data set where I am trying to make it a circle, that there are only 5 observations whose values are smaller than 41. Now, let me come to the second category A2, this is going from 41 to 50. So, you can see here that the total number of observation whose values are smaller than 50. What are those things? 5 and the absolute frequency of group 1 and absolute frequency of group 2 of class 1 and class 2. So, this is here 5 and 3. And similarly, if you try to look at A3, A3 has a limit 51 to 60. So, this is trying to give you a value here which is the sum of all the absolute frequencies up to the third class, which is 5 plus 3 plus 3, that is 11. And similarly, for the A4, this is trying to give you the total of all the absolute frequency from class 1 to class 4, and similarly for the class 5, this is trying to give you the sum of all the absolute frequencies up to the class 5, and similarly this sixth and the last group is trying to give us the sum of all the absolute frequencies up to the class 6, and this is obviously going to be the total number of observation. So, this is what we mean by cumulative frequency. So, by looking at the value of the cumulative frequency, I can always find that how many values are smaller than this value. And now, the same thing I can just make general, and now I will say that instead of here 6 class interval, I have here k class interval in general, and there are total number of observation are here n, and these n observations are divided into k class interval, and these class intervals are denoted by A1, A2, Ak in such a way such that class A1 contains n1 observation, A2 contains n2 observation, and Ak contains here nk observations respectively. So, obviously, if you want to find out the relative frequency of the gth class, this will be here the number of observations in the gth class divided by the total number of observations, and j will goes from 1 to up to here k. And now, all this information can be combined together in this format: class interval, here I can write down A1, A2, Ak, then the absolute frequency n1, n2, nk, relative frequency F1, F2, Fk, and if required, I can also add the information on the cumulative frequency. So, this table what we have drawn here, this is called as frequency table or the frequency distribution. Why we call it distribution? Because we are trying to see how the values of a variable are distributed. So, now in this lecture, if you try to see, I have taken an example, and then based on that example, I have tried to give you the different definition, concepts, and how the things are implemented. But whatever I have done, that is manually. Now, in the next lecture, I will continue with the same example, but then I will try to show you that how the things can be implemented over the R software. So, you practice it, you try to learn it, you try to understand it, and we will meet in the next lecture. Till then, goodbye.